Hello everyone, welcome back to Quantum Science Hub. In this video, we will discuss about IGCSE Chemistry past paper questions which focus only for the topic of atoms, elements, and compounds that I compiled from the last 5 years past paper question. And this is the part 1 video. So here we go. Question 1. Which statement about the atoms of all the isotopes of carbon is correct? To answer this question, you have to know and understand what is the definition of isotopes. So isotopes are the elements with the same number of protons but different number of neutrons. So let's take one example here, 12,6 carbon. If you check in the periodic table, so this is the carbon, while the other isotopes you can take, for example, 11 and 6 carbon. The other one can be 13, 6 carbon. Okay, so they will have the same number of proton, which is 6, and different number of neutron. If they have different number of neutrons, that means they will have different number of mass. Okay, let's check the option here. They are all radioactive. Of course, wrong, right? Because carbon is a non-metal and it is not radioactive, so it's wrong. They have the same mass. Okay, so in here you can see the mass for the first carbon is 11, the second carbon is 12, and the third carbon is 13. So of course, they will have different mass number. So this one also wrong. They will have the same number of neutrons. So even from the definition, we know if isotopes will have different number of neutrons, right? But the same number of protons. So this one is also wrong. Next, they will have the same number of electrons in the outer cell. So what is the definition of electrons in the outer cell? So this is what we call valence electron. Okay, so how we configure this one? We will use the atomic number or the proton number, which is 6, and it's going to be 2, 4. So this is the valence electron. So they all will have the same number of valence electron, which is 4. So the correct answer here is D. Question 2. Element X has 7 protons. Element Y has 8 more protons than X. Which statement about element Y is correct? So the clue here is 8 more protons. So that means X has 7 protons while Y has 8 plus 7 because it has 8 more protons than element X, right? So 8 more than 7 is 15. Now let's configure this one. So the first cell is 2, the second cell should be 5. So all add up to 7, right? And for element Y is 2, 8, 5. Okay, so let's check the option. Y has more electron cells than X. Yeah, that's correct. If you see here, so this is the first cell, this is the second cell, and this is the third cell. Okay, so this is the first cell, the second, and the third. And that's correct because element Y has 3 cells while element X only has 2 cells. Next, option B, Y has more electrons in its outer cell than X. Do you think so? For element X, it has 5 electrons while element Y also has 5 electrons. So this statement is wrong because they have the same number of electrons in their outer cell. Next, Y is in a different group of the periodic table from Y. So different group, nope, they have the same group. Why? Because they have the same number of valence electron. So that means they are in the same group, which is group 5. So this statement is also wrong. Next, option D, Y is in the same period of the periodic table as X. So since they have different cells, so that means element X is at period 2, while here element Y is in period 3 of the periodic table because it contains of 3 cells, while element X contains only 2 cells. Okay, so the correct answer here is A. Question 3. The nucleus of a particular atom consists of 19 particles. 9 of them are positively charged and 10 of them are uncharged. Which statement about this nucleus is correct? So remember, what contained in the nucleus of an atom? It contains of a protons and neutrons, right? Or I can say this is the mass, because mass equals to P plus and proton plus neutron. So contain of 19 particles. So we can say the mass here is 19. 9 of them are positively charged. So what is positively charged? Yes, it is proton. So I can say proton plus neutron equals to 19. And the proton here is 9 and 10 of them are uncharged. So uncharged means neutral. So what is neutral in an atom? It is neutron, right? So 10 neutron equals to 19. So from here, I can say the proton is 9, neutron is 10, the mass is 19, and remember, in an atom which is electrically neutral, the number of proton is always equals to the number of electrons. So in this case, the electron is also the same with proton, which is 9. Now let's check the option here. The nucleus has a nuclear number of 9. So what is nuclear number? So nuclear number, it means it's the mass, right? So mass equals to 9. Nope, because the mass here is 19, not 9. Option B, the nucleus has a nuclear number of 10. So the mass here, it said that the mass is 10. Nope, it is not 9, it is not 10, but it is 19. Option C, the nucleus has a proton number of 9. Yes, it is. So the proton number here is 9. So that's correct. D, the nucleon has the proton number of 10. As we know, the number of proton is 9. It is not 10, right? So the correct answer here is C. Question 4. Which statement explains why isotopes of the same element have the same chemical properties? Okay, again, what is isotopes? Isotopes are elements with the same number of protons but different number of neutrons, right? Okay, option A, they have the same electronic structure. Yes, because this is the reason why they have the same chemical properties. Okay, they have the same relative mass. No. Since they have different number of neutrons, of course, their mass will be different, right? So this is wrong. Option C, they have the same nuclear number. Again, nuclear number, it means it is the mass itself. So since they have different number of neutron, then they will have different number of nuclear number or the mass number. So this is wrong. Option D, they have the same proton number. Okay, this statement is correct. But please remember, chemical properties of an element depend on how its atom interact with other atoms, and that is how they form and break chemical bonds. So these interactions are determined by the arrangement of electrons in the atom, especially those in the outermost cell or the valence electron. So option D here, it is said that they have the same number of protons. This is a true statement, but this is not the reason for having the same chemical properties, because it's the same electronic structure that causes this. Isotopes have the same electronic structure, so that means they will have the same chemical properties, but different number of neutrons, and that is the reason why they will have different physical properties like mass or density. So the key phrase in the question is, which statement explains, so this is the key phrase, explain why isotopes of the same element have the same chemical properties. So even though the same proton number causes the same electronic structure, the direct explanation for same chemical properties is that they have the same electronic structure. So they have the same proton number, so this is true, but this is the cause of the same electronic structure. And option A here stated that they have the same electronic structure. Yes, and this is the reason for the same chemical properties. So therefore, the best answer is still A. Because chemical reactions depend on the arrangement of electrons, not the proton directly, even though protons determine the electron arrangement. So you can think of it like this. So proton number determines electronic structure, and electronic structure determines chemical properties. Okay, so that's why the answer is A. Question 5. X and Y are two different elements. X and Y have the same number of nucleons. which statement about X and Y is correct. So in here, we have two different elements. Since they are different, so that means they will have different number of protons. Let's assume the number of protons for X is 10 and Y is 11. X and Y have the same number of nucleons. Again, nucleons, it means it is the mass number, right? And the mass number usually is about the 2 times of the proton number. So if I have proton number of 10, so the nucleon or the mass number is going to be 19, 20, or 21. Let's say the mass number here is 20. And here will also 20 because they have the same number of nucleon, right? Now let's check the answer. Option A, they have the same physical properties. Okay, so this is wrong because since they are different elements, it means they will have different physical properties, right? Next, their atoms have the same number of electrons. So in an atom, the number of electrons is always the same with the number of protons. So in here, for element X, the number of proton is 10. Then the number of electron is also 10. Same with element Y, the number of electron is 11. So you can see in here, they will also have different number of electrons, right? So this is wrong. Next, they are in the different group of the periodic table. If we configure the electronic structure of element X, it's going to be 2, 8. So the valence electron is 8. So that means it is at group 8. And element Y has 11 number of protons. So that means the electronic configuration is 2, 8, 1. So the valence electron is 1, then it is at group 1. Okay, so they are in different group of the periodic table. Yes, it is. Next, they will have different relative mass. So the relative mass here is the same with the number of nucleon, right? So from the statement, from the question, we already know they have same number of mass, right? So that means they will have the same number of relative mass because they have the same number of nucleons. It's not they have different relative mass. So this option is wrong. So the correct answer here is C. Question 6. Which two particles have the same electronic structure? Okay, to do the electronic structure, then you have to see the periodic table and find the proton number or atomic number, right? So in this case, if you check in the periodic table, you will see if the proton number of carbon is 6, so 6 carbon, then we configure this one. So how we configure carbon? 2, 4, right? While oxygen, the atomic number is 8. So how we configure this one? 2, 6. But since it is 2 minus, or this is oxygen ion, so you receive 2 more electron, then you become 2, 8. So this is the electronic configuration or the electronic structure of carbon and oxygen ion. They are different, right? Carbon is 2, 4 while oxygen ion is 2, 8. Next, fluorine is 9. So how we configure this one? 2, 7, right? Since it is fluorine ion, so you will receive 1 more electron. So now you become 2, 8. And sodium is 11. So it's going to be 2, 8, 1. So this is the electronic structure, right? They are still different. Next, option C. Potassium, if you check in the periodic table, is 19. So 2, 8, 8, 1. Since it is potassium ions and it is positive, so it's better for you to remove 1 electron. Now you become 2, 8, 8. Next, sulfur. Sulfur is 16, right? So how we configure this one? 2, 8, 6. And since it is 2 minus, so that means you receive 2 more electron. Now you become 2, 8, 8. So you can see in here, they have the same electronic structure. So C is the correct answer. But let's continue with option D. Mg is 12, right? So how we configure this one? 2, 8, 2. And sodium is 11. So how we configure this one? 2, 8, 1. Since it is sodium ion and the charge is positive here, so it's better for you to remove one electron. Now you will become 2, 8. So this is the electronic structure for option D. So it's very clear the correct answer is C. Question 7. There are two stable isotopes of bromine. The mass number of isotope 1 is 79. The mass number of isotope 2 is 81. Which statement is correct? So what is the definition of isotopes again? Isotopes are elements with the same number of protons but different number of neutrons, right? So option A and C here is wrong, okay? Next, do you think that the isotopes have different chemical properties? Since their protons are equals or they have the same number of protons, so that means they will have the same electronic configuration, and as the result, they will have similar chemical properties, right? So this one is wrong. Now option D, the isotopes have the same number of outer electrons. Yes, it is because they have the same number of protons. That means they will have the same electronic configuration, and as the result, they will have the same number of valence electron or electrons at the outermost shell, right? So the correct answer here is D. Question 8. Which row about elements, mixture, and compound is correct? Okay, so in this option, we have copper, methane, brass, and sulfur. Since we are still in chapter 2, so I assume that you don't know what is methane and brass. So in this case, I will just analyze by using copper and sulfur. So remember, everything that is written in the periodic table, they are all elements. So that means copper is an element and it's a metallic element, right? So this is correct. While sulfur, you can also see it is in the periodic table. So that means sulfur is also an element. It is not a compound. So in this case, option A and option D is wrong. What about option B? Sulfur is a non-metallic element. Yes, that's correct. And copper, you can find it in the periodic table. So that means copper is an element. It is not a mixture. So in this case, option B is also wrong. So from here, I know that my correct answer is gonna be C, even though I don't know what is brass and methane. So this is the way how you answer multiple choice questions quickly and accurately without knowing the entire option in here. So you just need to use what is your knowledge based on what you know. Okay, now let's go back to methane. So what is methane? Methane is CH4. This is the formula of methane, and this is a compound. Okay, so just like water, H2O, or ammonia, which is NH3, this is also a compound. And brass is an alloy. So if you still remember what is alloy, alloy is the mixture between two or more different metals, right? So it is the mixture between copper and zinc. Okay, so it is a mixture. So the correct answer here is C. Next, question 9. The atomic number of 4 particles W, X, Y, Z are shown. Which particles are isotopes of the same element? Again, the question is asking about isotopes. So you have to know what is the definition of isotope. So what is isotopes? Isotopes are elements with the same number of protons but different number of neutrons, right? So from here, let's check it out. Same number of protons, so these and these, or maybe you can say these and these, but different number of neutron. So in here, the neutron for W and Z, they still have the same number of neutron, right? So in that case, you can choose W and Y because the neutron number is different, but they have the same number of protons, right? So this is very easy. So the correct answer is B. Next, question 10. An atom of element X contains 5 protons, 6 neutrons, 5 electrons. Which statement about element X are correct? Okay, so we know they have the same number of proton and electrons. So that means this element X is an atom, right? Since they have the same number of proton and electron. If they are different, the number of electrons and protons are different. So that means they are not atom, but they are ions, okay? Okay, now let's check the statement here. X has an atomic number of 6. Again, what is atomic number? So it is a proton number. And the proton number here is not 6, but it's 5. Next, X has nuclear number. So what is nuclear number? The nuclear number is the mass number, right? So if you still remember the formula again, so mass equals to P plus N. So equals to P, it means proton. How many proton it has? 5, and N is neutron, so 6. So 5 plus 6 is 11, so that's correct. X is in group 2 of the periodic table. So to know this, we have to configure the electronic configuration of element X, right? So we are using the proton number. So how we configure this one? 2, 3. So it means it is in the group 3 of the periodic table, not group 2, right? So it's wrong. Next, X is in the second period of the periodic table. So how do I know the second period? Because it contains of 2 cells, right? So this is the first period and this is the second period, okay? So yeah, that's correct. So the correct answer here is 2 and 4, which is D. Question 11. Which statement about an atom of fluorine 99 fluorine is correct? Okay, so this is an atom. So in an atom, the number of protons equals to the number of electrons, right? So this is the proton number. So the proton number is 9. Electron is also 9, while the mass is in here. So the mass is 19. Remember, mass equals to proton plus neutron. So how many proton? 9 plus the neutron, we don't know because we have to find it, while the mass is 19. So the neutron equals to 19 minus 9, which is 10, right? So now let's check the option here. It contains of a total of 28 protons, neutrons, and electrons. So altogether, so the proton here is 9, right? And neutron is 10, and electron is 9. So altogether, they made up of 28. So that's correct. Next, it contains more protons than neutrons. The proton is 9 and the neutron is 10. So it means the neutron is more than the proton, right? So this one is wrong. Its isotopes contain different number of protons. So one more time, what is the definition of isotopes? Isotopes are elements with the same number of protons but different number of neutrons. In here, it says that it contains of different number of protons. So it is wrong. It should contain of the same number of protons. Next, its nucleus contains 9 neutrons. While the neutron here, we already find it. The neutron is 10. It's not 9. So this one is also wrong. So the correct answer is A. Question 12. 2 of the isotopes of calcium are represented as this and this. Which statement explains why these isotopes of calcium have identical chemical properties? So let's check one by one. Both isotopes have the same number of neutrons. So you can see in here, they already have different mass number. So that means they will have different neutron, right? Because mass equals to proton plus neutron. Their mass is different. So that means they will have different number of neutrons. So this is wrong. Both isotopes have an electronic configuration of this. Okay, so we are taking the proton number or the atomic number of calcium, right? So it's going to be 2882. So that's correct. Both isotopes have a mass number of 20. Nope, it's not the mass number, but it's the proton number, right? Okay, so it is wrong. Both isotopes have 4 fully occupied electron cells. For the first shell, the maximum number of electrons allowed is 2, so this is correct. The second is 8, the third is 8, and the fourth is also 8, but this one is 2. So this one is wrong. So the correct answer here is B. Question 13. 4 statements about atoms are listed. Okay, so this is about the atomic structure, right? So remember, in the nucleus, it contained of neutrons and protons, right? While the electron is orbiting or located at the electron cell, so it's not in the nucleus. So the electron is in here, right? So this is electron. And same in here. It can be at the first cell, it can be at the second cell, and the third cell, and so on. Okay, now let's take a look at the statement here. The center of an atom is positively charged. Yes, remember neutron has no charge, while proton, the charge is positive. So yes, it contains of positively charged, right? Because it's contained of protons and neutrons. So this is correct. Next, protons and electrons are located in the nucleus. Only for protons that is located in the nucleus, not electron, because electron is located at the electron cells, which is outside of the nucleus. So this statement is wrong. Protons and electrons have the same mass. So the relative mass of proton is 1, while the mass of electrons is 1 out of 1836. So it means they have different mass, right? So this statement is wrong. Next, most of the mass of an atom is in the nucleus. Okay, so if you still remember the formula, mass equals to P plus N, proton plus neutron. Yes, it is the mass. So because it is located in the nucleus, which is proton plus neutron. So most of the mass of an atom is in the nucleus. Yes, that's correct. So we know the correct answer here is 1 and 4. So the answer here is B. Question 14. The electronic configuration of 2 elements are given. Element L 2881, element M 284. Which row identifies the group number and the period number for element L and element M? So remember, how do we determine the number of group? The number of group is determined by the valence electron, right? The valence electron here is the electron at the outermost shell. So for element L is 2881. So this is the first cell, this is the second cell, the third cell, and this is the fourth cell, while the valence electron is here. So that means it is at the group 1, while here is the period 1, period 2, period 3, and period 4. So the number of cells determines the number of periods. So from here, I know it is period 4. While element M is 284. So this is the first cell, this is the second cell, and this is the third cell. So the valence electron is 4, so that means it is at group 4. And it is at period 3. So which one matches the answer? Yes, so the correct answer here is A. Because for element L, it's group 1 and period 4, while element M is group 4 and period 3. Question 15. The only naturally occurring isotopes in a sample of europium are 151 EU and 153 EU. This sample of europium has a relative atomic mass AR of 152. What is the percentage of 151 EU present in this sample to 3 significant figures? Okay, please remember that each isotope has its own mass number. For europium here is 151 and 153. A sample's relative mass is the average mass of all atoms in the sample, weighted by how common each isotope is. So in this case, let's say 151 EU is X. So the fraction of 153 EU is going to be 1 minus X. So how is the average mass? This is going to be 151 times with X and plus 153 times with 1 minus X equals to the 152. So 151 times X is 151X plus, you times it inside here, it's going to be 153 minus 153X equals to 152. So minus 2X equals to minus 1. So X equals to minus 1 divided by minus 2 is going to be half, right? So X equals to 0.5. So in percentage, this is going to be 0.5 times 100%, so equals to 50%, right? So let's check if this answer makes sense. The average of europium is 152. It is exactly halfway between 151 and 153. So if the average is exactly the midpoint, then the two isotopes must be present in equal amounts, which is 50%. So if I draw it, it's going to be like this. So this is 151 EU, which is 50%, and this is 153 EU, which is also 50%. Their average mass is 152 EU, and they all made up to 100%, right? And the question is stated in 3 significant figures, so the answer here is B. Now it's your turn to solve the rest of this multiple choice past paper question. You may pause the video to think for a while and please write your answer in the comment section. I will check and give a reply for every comment. Question 16. Question 17. Question 18. Question 19. Question 20. Next, let's move to the structure question. Question 1. This question is about element X, Y, and Z. An atom of element X is represented as 3416X. Name the different types of particles found in the nucleus of this atom of X. So if you still remember the structure of atom, so in the nucleus it contains of proton and neutrons, while the electron is orbiting here at the electron cells. So this is the electron in here. Okay, the maximum number of electrons allowed in the first cell is 2, the second and the third cell is 8. Okay, so please remember the rule again. So the question is asking, name the different types of particles found in the nucleus of this atom of X. So what you can find in the nucleus, you can find protons and neutrons. Okay, next, what is the term for the total number of particles in the nucleus of an atom? So the total number here is it's proton and neutron. So what is proton and neutron? It is the mass number, right? So you can say this is mass number, or in other words, you can also say this is nucleon number. Okay, next, what is the total number of particles in the nucleus of an atom of 3416X? So it is stated that in the nucleus is the total number of proton plus neutron, which is the mass, and the mass is in here, the bigger number or the upper side of this symbol, right? So it is 34. Next, what is the electronic structure of the ion X2-? So we are using the proton number or atomic number to do the electronic configuration, right? So it is 16x. So how we configure this one? 2, 8, 6. So how to become stable? You can remove 6 or you can gain 2 more electrons. So you can become 8, right? So it's easier for you to gain 2 more electrons rather than you remove 6. So you gain 2 more electrons, so you become 2, 8, 8. So this is the valence electron right now, okay? Because ions is the stable one, while atom is not stable, right? So electron is something negative, so you gain something negative to yourself, so you become more negative. So that's why the symbol for the ion of X is 2-, right? So the electronic structure of X2- is 2, 8, 8, okay? Not 2, 8, 6, because 2, 8, 6 is for atom, while the ions is already complete, which is the valence electron is full. In this case, it is 8. So the electronic structure for ion X2- is 2, 8, 8. Next, part B. What term is used to describe atoms of the same element with different number of particles in the nucleus? So I think this one is very clear. It is called isotopes, right? So the answer here is isotopes. Next, identify the atom against which the relative masses of all other atoms are compared. So scientists needed a reference atom to compare the masses of all other atoms because atoms are extremely small and light. Scientists choose carbon-12 as the standard because it is stable, common, and easy to measure accurately. It's very common in nature, which means carbon can be found everywhere, in the living things, in the air as carbon dioxide, and in many materials. It is very stable, and the carbon-12 isotope doesn't decay because it's not radioactive, so its mass stays constant. So this is the reason why carbon-12 is the standard atom used to define and compare atomic masses. Okay, so in here, the answer is carbon-12. Next, part C. Part of the definition of relative atomic mass is the average mass of naturally occurring atoms of an element. Some relative atomic masses are not whole numbers. Element Y has only 2 different types of atoms, 69Y and 71Y. The ratio of atoms present in element Y is shown. So it's 3:2, right? Next, calculate the relative atomic mass of element Y to 1 decimal place. Okay, so if you still remember the formula of counting atomic relative mass, okay, so this one is AR, or atomic relative mass, is the total of the mass of isotopes and then times with the percentage abundance divided by 100%. Okay, so it depends on the question. If the question is given in percentage, then you divide by 100%. So in this case, it is not in percentage, but it is in ratio. So we can count it as by using the ratio, which is 3 times the mass of the first isotope, which is 69, and then plus 2 times the second isotope, which is 71. Okay, so this 3 is belong to 69Y and 2 belong to 71. Divide by the total ratio, which is 3 plus 2, which is 5. So you will get 3 times 69 is 207 plus 2 times 71 is 142 and divide by 5. So you will get 349 out of 5. So equals to 69.8. So the answer here is 69.8 because he asks you to answer it in 1 decimal places, right? Identify element Y. So 69.8, so this is almost 70, right? So what is the element with the mass of 70? So you can check in the periodic table. So if you see in the periodic table and use this as the reference, so the atomic number is at the upper side in here, right? And this is the atomic symbol, and the relative atomic mass is at the bottom. So this is the place, right? If you see, this is the mass and this is the atomic number. So the element is gallium, okay? So the answer here is gallium. Next, part D. Element Z is in period 3 and group 5. Identify element Z. So in this case, let's see in the periodic table. So this is the periodic table. So where is period 3? So this is period 1, which contains only hydrogen and helium. This is period 2, and this is period 3. And group 5. So this is group 1, group 2, group 3, group 4, and group 5, right? So 1, 2, 3, and 5. So this is phosphorus, right? Okay, so the answer is phosphorus. So we write in here, you can write the name, which is phosphorus, or you can also write the symbol, which is P, okay? Now explain in terms of electrons transfer why Z behave chemically as non-metal. If you still remember in the notes, all metals, the charge of the ion contains of positive 1 or 2 or 3. Okay, so that means all metals transfer electrons. While Z here behaves chemically as a non-metal, so that means it gains electrons, right? So you can say because it gains electrons when forming ion. Okay. Next, question 2, part A. Chlorine is in group 7 of periodic table. Two isotopes of chlorine are chlorine 35 and chlorine 37. State why these two isotopes of chlorine have the same chemical properties. So if you still remember with the notes, so why all isotopes have the same chemical properties? Because they have the same number of electrons, and therefore they will have the same electronic configuration, right? Okay, so that is the answer. Next, part B. Complete the table to show the number of electrons, neutrons, and protons in each atom and ion. Okay, so we have 3517 chlorine atom and 3717 chlorine ion, okay? So if you still remember, in an atom, the number of protons is equal to the number of electrons, right? So proton is 17 while electron is also 17 because this is the proton number or the atomic number, okay? While neutron, how to find neutron? So we have to know the mass number, right? In here, the mass is 35. So mass equals to, if you still remember, mass equals to proton plus neutron. So that means neutron equals to mass minus proton, right? The mass is 35 and the proton is 17. So 35 minus 17 is 18. So in here, the answer is 17, 18, and 17. Next, for 3717 chlorine ion, we have 17 proton, while the electron, because the charge is negative, right? So that means you have one more electron, because electron is something negative, right? So you have one more electron than the proton. So in an atom, the number of electrons is equal to the number of protons, right? So the electron here should be 17 plus one more charge, one more electron from the number of protons. So 17 plus 1 is 18. And the number of neutron is the mass minus with the number of proton. The mass here is 37. 37 minus 17 is 20. Okay? So the answer is 18, 20, and 17. Part C. Magnesium reacts with chlorine to form magnesium chloride. Complete the dot and cross diagram to show the electron arrangement of the ions in magnesium chloride. Give the charges on the ions. The inner cells have been completed. Okay, to answer this question, you have to know the atomic number or proton number for each atom. So if you check in the periodic table, the atomic number of magnesium is 12. So 12 magnesium, how we configure this one is 2, 8, 2, right? So how to make it stable? So it's better for you to remove 2 electrons at the valence shell. So now it will become 2, 8. Okay, so this is the valence electron. And this is the first cell, and this is the second cell. Now for chlorine, you will find in the periodic table it's 17. So how we configure this one? 2, 8, 7. Okay, how to make it stable? It's better for you to receive one more electron, and you will become 2, 8, 8. So this is the valence electron, which is already complete, right? So this is the first cell, this is the second cell, and this is the third cell. Okay, let's draw and complete the dot and cross diagram. So for magnesium, it only contains of 2 cells. The first cell is 2 and it's already full, which is 2. Now the second cell should be 8 because they are using cross and you are also using cross in this case. 4, 5, 6, 7, 8. Okay, how many electrons that you remove at the valence shell? You remove 2 electrons, so that's why you will become 2 positive. The charge here is 2 positive because electron is something negative. So if you remove something negative from your side, you will become more positive, right? Since you remove 2 electrons, so the charge here is 2 positive. Okay, now let's see for chlorine. So this is the first cell, 2 electron, right? So this and this. And the second cell is already full, which is 8. And the third cell is also 8. So they are using dot, so that's why we are also using dot. So 1, 2, 3, 4, 5, 6, 7, and the last electron, you gain it from another atom, right? It is not from your cell, but it is from another atom. So that's why we cannot use dot for the last electron, but we are using cross. Okay? And how many electrons that you gain? You gain 1 electron from another atom. So that's why the charge here is -1. Next, question 3. Complete the table to deduce the number of protons, electrons, and neutrons in the magnesium atom and copper ion shown. Identify the atom or ion represented by the final row. Okay, so in this case, remember, in an atom, the number of proton is equal to the number of electron. So this is an atom, right? The number of proton is 12. So in this case, the number of electron is also 12. And the number of neutron is determined from the mass. So mass equals to proton plus neutron. So the mass here is 25 and proton is 12 plus neutron. So neutron is 25 minus 12, which is 13. So the answer here is 13. Okay, for copper ion, the number of proton is 29 because it's just like this. You can take this one, the atomic number or the proton number stated in here at the bottom part. While electron, you can see this is ion and the charge here is 2 positive. So that means you have 2 more proton than electron. So that's why the number of proton is 27. So that means the number of electron is 2 less than the number of proton. Because the charge of protons is positive and the charge of electron is negative. If you have 2 more proton, which is positive, then the charge here is 2 positive. Okay, now which atom that we state in here? Do you think this is atom or ion to fill this place? Okay, so it's gonna be ion, right? Because you can see the number of proton is 17 and the number of electron is 18. So it is different. And if you check in the periodic table, what is the element with atomic number of 17? Yes, it is chlorine, right? So chlorine 17 and the mass here, mass equals to Pn, right? P plus N. So the proton is 17 plus neutron is 20. So the mass is going to be 37. So 37, and do you think that is how many is the charge? You have one more electron. Electron is something negative. You have one more negative, right? So that's why the charge is negative. So that is how you do it. Question 4. Atoms are made of electrons, neutrons, and protons. Part A. Complete table 2.1. So we just need to complete this table. What is the relative charge of electron? The relative charge of electron is -1, right? Because electron is negative and proton is positive. So positive 1. And what is the mass for neutron? The mass for neutron is 1 and proton is also 1. Okay? Part B. Atoms of the same element are known as isotopes. 3919K and 4119K are isotopes of potassium. Complete table 2.2 to show the number of electrons, neutrons, and protons in one atom or ion of these isotopes. In this case, this is atom, right? Remember, atom doesn't have charge at all, while here you have the charge. It can be positive, it can be negative, right? So this is ion. So remember, one more time, in an atom, the number of proton is equals to the number of electrons. So in this case, this is the number of protons, right? Or atomic number. So the proton number is 19 and the electron number is also 19. And what about the neutron? So mass equals to P plus N. So the mass is 39 and the proton is 19 plus N. So neutron is 39 minus 19, which is 20. Next, so this is the proton number, right? So the proton number is 19, but the charge here is positive. So that means you have more proton than electron because proton is positive while electron is negative. So how many electrons? So that means you will have 18, right? Because you have one more protons than the electrons. So that's why the charge should be positive. And this is positive 1. Then what about the mass? Mass equals to P plus N. So the mass is 41 equals to 19 plus N. So N equals to 41 minus 19, which is 22. So the neutron here is 22. Okay? Very easy. Next, table 2.3 shows the relative masses and the percentage abundance of the two isotopes in a sample of potassium. So this is the relative mass and this is the percentage abundance of isotopes. Calculate the relative atomic mass of the sample of potassium to 1 decimal place. Okay, if you still remember how to calculate the atomic relative mass, it is the mass and then times with the percentage, because in here they give in percentage, right? So it's gonna be 39 times 90 and then plus with 41 times 10 divided by 100%, right? So this is 3, 5, 10 plus 410 divided by 100. So this is gonna be equals to 3,920 divided by 100. So equals to 39.2. Okay, so the answer here is 39.2. Next, an isotope of aluminum has a nuclear number of 27. Aluminum has a relative atomic mass of 27. State what conclusion can be made from this information. Since the isotope has a nuclear number of 27 and the relative atomic mass of aluminum is also 27, so this shows that almost all naturally occurring aluminum atoms are the same isotopes, which is 27. There are no other isotopes in the significant different amount to change the average atomic mass. So from here, I can say that aluminum has only one stable isotope, which has nuclear number of 27. Okay, so that's the answer. Part C. A calcium atom has the electronic configuration of 2 882. Give the formula of one atom and one negative ion that has the same electronic configuration as Ca2+. So this is Ca, right? This is calcium. So the configuration is 2882, while Ca2 positive, so that means you remove these 2 electrons and now you will become 288 because you remove something negative. That's why you become more positive, and that's the reason why the charge here is 2 positive, because you remove the electron, you become more positive. And how many that you remove? You remove 2, so that's why it is 2 positive. Okay, so the total number of electrons right now is 2 plus 8 plus 8, which is 18, right? Okay, so what is the atom that have the same atomic number or the same proton number of 18? If you check in the periodic table, who has 18 proton number? So the answer is Ar, argon, right? This is the proton number. So the answer here is argon. And you have to read the question carefully because the question asking you not to write the name but give the formula, okay? The formula or the symbol. So it's gonna be Ar, okay? Don't write argon. Next, negative ion. Okay, if you check again, what kind of ions that have the same weight 18? So you can use 17, okay? For example, 17x minus. So it's gonna be 287, and then you gain one more electron. Now you will become 288, okay? Or maybe you can use 16, but you gain 2 more electrons. So it is also the same, 286, and you receive 2 electrons. Or maybe you can use 15. The charge here is 3 minus, so it's gonna be 285, and you will receive 3 electrons. Okay, so the electronic configuration after they become ion, they will have the same electronic configuration, which is 288. So which one? So in this case, you can use 15 phosphorus, 16 sulfur, or 17 Cl. Okay? Okay, so phosphorus is 15, right? So you gain 3 more electrons, so that's why you become 18. So you can write P3 minus, okay? Or maybe you can write sulfur. Sulfur is 16, so you gain 2 more electrons. Now you become 18. And the ion of sulfur is going to be 2 minus. Or you can use chlorine. Chlorine is 17 Cl, right? And then you gain 1 more electron, so you become 18 as well. So Cl minus, okay? But you just choose one of them, not write them all. Okay, that's the answer. Now it's your turn to solve this question. Please leave your answer in the comment section, and for sure I will check and give you a feedback. Number 5, Part A. And this is for Part B. So that's all about some past paper question in this Part 1 question and answer. Thanks for watching. Don't forget to like, comment, and subscribe. See you again.